Okay, last problems, last two. A person is pushing a 1.7 kilogram measures mass, 1.7 kilogram block up a 35-degree incline with a force of 18 newtons directed up the ramp. The coefficient of kinetic friction between the block and the ramp, between those two surfaces, is 0.45. Find the block's acceleration up the ramp. I draw my pictures so that the block always moves to the right across my page. So if it's accelerating up the ramp and moving up the ramp, then it's going to go to the right when my ramp looks like this. So this angle theta is 35 degrees. The block has some forces acting on it. I'm going to move my block over so I have room for the forces. There's gravity, of course, pulling down. The normal force pushes off the ramp. Move all this. Normal force pushes off the ramp. In addition, kinetic friction opposes its motion up the ramp, but then the person is pushing it up the ramp. We know that mg is at an angle to our tilted axes. Right, so one axis is like that, all like that, and the other axis is perpendicular to the ramp. So mg has a perpendicular component, or a tilted y component, and a tilted x component. I'm going to move mg to the hypotenuse right there. And that's the right angle, right? So mg is the hypotenuse. The two components, one is adjacent, one is opposite. The angle that we know is this angle. If 35 is the angle of the incline, then that angle also is 35 degrees by similar triangles. And it's easy to prove. Opposite 35 degrees is hypotenuse. Mg is the hypotenuse, right? Because it's opposite the right angle. So hypotenuse times the sine of theta. And then adjacent is hypotenuse cosine theta, like that. The block doesn't accelerate off of the ramp. It's not levitating or floating off. It's also not accelerating into the ramp. It doesn't crush the ramp. It just accelerates up. That means the total y force is 0, and the normal force equals or balances mg cosine 35, this tilted y down force. Okay. We have to find the acceleration. If the total y force is 0, then we can ignore the y direction and say the total x force is where we have, the x direction is where we have acceleration. So we can apply Newton's second law just to the x direction. And that's legal. We can do that. That's good to do. So in order to solve for the acceleration, the unknown, we'll need to know the mass and all of the forces on the x-axis, on the tilted x-axis. So what are the forces on the tilted x-axis? I mean, I see friction, which is left. I see this one, which is left. Both of those are negative because they point left. And I see Fa, which is right. So let's add up those forces right here, right now. Let's do it. Add up the x forces and replace the sum on the left side with the actual forces themselves. So we said Fk is left, negative makes it left. The other left force was this one. I see that the point's left in my picture. And because it's left, again, because it's left, it's negative. Mg sine 35. And then what else is there? There's the applied force pushing up the ramp. And all of that equals m times the x acceleration. Right. Now, the x acceleration is the unknown. We know mass. We know the applied force. It's 18. We know m, that's 1.7. G we know. 35 is known. All we need to find before we solve for acceleration, all we need to find is Fk. Okay. So how do we find Fk? It's pretty simple. Mu k times normal force. The normal force is mg cosine theta. Right. Mu we were given in the problem. My colors are all off. What was mu? They told us it was 0.45. Fk, I'm sorry, Fn, the normal force, right here again, is m g, it says, 9.8, cosine 35. So calculate that out, and you get 6.14 for Fk. Alright. Aha! Now we know that. It's 6.14. Whoa. So let's move this over. And let's finally solve for the acceleration. Fk, 6.14. M was 1.7 times 1.9. Sine 35. Oh, I'm running out of room. Fa, the applied force, was 18, I believe. 18, and it's up the ramp. That was pointing to the right, so it's positive. Again, 1.7 there, and AX. 18, right? Yep. 18 directed up the ramp. So, negative 6.14 plus... Oh my gosh, look at this. This is no good. mg sine theta points to the left. So that's negative. So it's negative 1.7 times 9 point. mg. G is not 1.9, is it? Long day. Sine theta. Plus 18. And then we have to divide everything by 1.7. And you get 1.4 meters per second squared. That's the acceleration up the ramp. Last one. Block is being pushed and also moved as well. Moved up a 26-degree incline or ramp. And this time we have constant velocity. So here's the ramp. There's the block. It's moving up. The problem really should say moving up the ramp. And why is it moving up? Because there's a pushing force directed up the ramp, an applied force. And what else are we given? We're given the mass of the block. The mass is 1.3. The coefficient of kinetic friction is 0.38. Right? So we have to find the person's pushing force. That's our unknown. So what else acts on the block? Well, there's gravity pulling down. The normal force pushes perpendicular, because normal means perpendicular. And then friction, kinetic, opposes the motion of the block. So let's put Fk. Right. So what are the forces? That's it. That's all of them. But mg, of course, has a tilted y component and a tilted x component. Theta here, and also this theta, those are both 26 degrees. Okay. So these are, the red lines show our components. I'm going to move mg to the hypotenuse, because it's the hypotenuse of our right triangle, of our tilted right triangle. This bottom side is opposite theta, so it's mg sine theta. And this one right here is mg cosine theta. And why don't I replace theta with 26? Like that. Okay. Because we have constant velocity, total force is 0. Up balances down, left balances right. We have balancing of our forces. So how am I going to find the applied force? You can already see the way we find the applied force is by balancing the rightward forces with the leftward pointing forces. So all of the forces pointing right give us just Fa. When we add up all of the forces pointing left, we get the Fk force points left. What else points left? Mg sine theta points left. Fk, we need to find Fk before we can solve for F sub A. So let's find Fk. It's equal to mu times the normal force. And mu we know, it's 0.38. What about the normal force? Normal force. Well, the normal force is an up force. We have balancing, right? Balancing. So the up force balances the down force. Those are equal. Fn balances mg. It equals mg cosine the angle. So down here for Fn, right there, I'm going to replace it with what it equals, mg cosine theta. And so I get m, which is 1.3, times g, 9.8, times cosine, 26. And I calculate that out. And I get 4.35. 4.35. So then, right here, I replace that with 4.35. M, I replace with the value 1.3. G is 9.8. Sine 26. You calculate the right side, evaluate the right side, a fancy way of saying calculate. And what do we get? We get 9.9, almost 10. 9.9 newtons is our answer.